We're going to get started going through the CFA here from lessons 1.8 and 1.10, 1.11, and 1.12. Make sure you are following along with your hard copy and writing in answers here so you have a study guide for your test. So getting going here, guys. Sophie's going to the swimming pool and she's going to swim in some different spots. So our job is to mark on this number line where she's at. Okay, so I'm going to start out here at the beginning where it says she decides to swim in the shallow end first because it is only 3 feet deep. Okay, and then I'm going to mark that location. So 3 feet deep means we're on the negative side because she's under the level ground. So she's at a -3. And mark my spot right there at this location. It doesn't say to label it, but I'm going to go ahead and label it that she's in the 3 foot now here, which is the shallow end, but she's below the water, so we're on the negative side of that number line. Then it says she swims to the middle of the pool, which is 5 feet deep. So we're going deeper. Okay, and now she's at a -5 below the ground level. Now she's in the 5 foot, in the middle of the pool. Sophie then takes a break and sits on her towel for a few minutes. So she's out of the pool now. So she's at 0. She's at the ground level and she's sitting on her towel. So I'll just label it there because she's not below the water. She's not up above the water. She's right at ground level. Then she decides after that she's going to climb a ladder to the 6 5/10 foot high diving area. So now she's above the ground on the diving board. So 6.5, 6.5, so she's between 6 and 7. I'm going to label it right there, and she's on the diving board. And finally, she jumps in to the 10-foot deep end. So now she's clear down here at the bottom, the 10 foot that goes very deep after she jumps off that board, and she swims there for the rest of the day. So she's here at the deep end where it goes a lot deeper. Okay, so now we've got all of our numbers labeled here on our number line, the positive and the negative. Okay, so make sure you get all these written down here, and we will go ahead and take a look here at the other side. Number 2, we're looking at a histogram here of the number of gifts received for birthdays. And if it looks like here, we've got between 0 and 1, 2 and 3, 4 and 5, 6 and 7, and 8 and 9. So we've got 5 different bins there, and it looks like they're going by ones over here. All right, and we know sometimes they can label these things different things to make them look a little different. But in this case, all we're doing is describing the shape of this data. So if I'm looking at this data here, kind of starts this gradual hill, and it comes down a little bit more. I know down here it dips a little bit more, and you could draw it dipping in there a little bit, but it's kind of on a hill all the way down, so sometimes this is just a general line. So to describe the shape of it, this is that hill that we call skewed. And it's skewed to the left because we have some outliers here that don't get as many gifts. When we know most people get around this amount of gifts, anywhere from 4 to 7, it looks like is pretty common here. So it's skewed to the left because some get a lot less than that, so kind of an outlier there. So let's just say it's skewed to the left. Again, lets us know there's some outliers and people there that get things that are not as common in this situation. All right. Number 3, we're going to look at these fraction strips here, and we're going to have to plot these on the number line. So label each point with its fraction name. So we'll just put the points on here with its fractions. Now I'm going to skim through these, and guys, what I notice is when I'm looking through all of these, I notice they're all less than 1 except 7/7. I know that's exactly 1. So I'm going to start with that one. And I'm going to put it over here, and I'm going to label it 7/7. If I want to put a little 1 above it to remind me that's 1 whole. And I know this isn't on the number line, but I'm going to put 0 right here. Or I know that's not one of my choices, but I know all of these are between 0 and 1. So I'm going to put that there at the end here with my tick, just so I know I'm going between 0 and 1 here. As I skim through them also, I want to cross out the ones I've used to stay organized. Something else sticks out to me. 6/12. I know that's half because 6 is half of 12, so I'm going to go about halfway here and put in my 6/12. Start with the ones I know very well. Other things I see when I look through there. I see 6/8. And I know 6/8 in simplest form is 3/4. Okay, so that's another way to look at this, and I know it's greater than a half, and I know if I cut that in half, this would be like 3/4, because I could do fourths and get 1/4, and 2/4 would be half, and 3/4 would be right here. So again, I'm going to label this 6/8. I know it's similar to 3/4, and I know it's greater than a half, so it makes sense that it goes right here. If I did have 1/4, I would mark it right there, so then I could think, well, this is 1/4, 2/4 is half, this is 3/4, and then 4/4 would be the whole thing. So, you know, I can put some ticks down there that can help me, even though they're not ones that I'm going to use on here. But I'm going to erase that for now, so I don't make it so messy up in there. Okay, so I've used 6/8. 2/6. I look at 2/6, and I know in simplest form that is 1/3. You know, I know that is less than a half because 3 is half of 6, and I only have 2. So I know it has to be less than a half. And if I imagine putting this whole number line in thirds, 3 equal parts, I put like a tick here and another tick around over here. I'd have 1/3, 2/3, 3/3 of the whole thing. So just by kind of eyeballing it there, I'm going to think this is 2/6, which is 1/3, and that's going to be pretty close there. I know that's less than a half. So it makes sense that it could go approximately there. So I'm left with 2 more, 7/9 and 3/8. And these get a little bit tougher because they're close to a couple of things that we have here. So when I look, let's start with 7/9. So I know 7/9 is close, is greater than 1, or greater than a half, excuse me. And it's getting kind of close to 1 if I have 7/9. All right, so I know it's going to be above half. All right, now my key is here, is it greater than 6/8 or not? So I'm going to take a look down here. I'm going to go do a little extra work. Let's go over here. I've got 7/9 and 6/8. They're both missing a couple of pieces there, right? A couple of 8s here and a couple of 9s. So you could use that to help you too. And some of you can do that. Just know which one's bigger because of the size of the pieces. But I'm going to think my common denominators here. I know 9 and 8 can both get to a 72. Okay? With the multiples for 72, they'd land at 72. If I take the 9 times 8, that got me to 72, so I got to take the top times 8, and I get 56 70-seconds. And if I take this 8, take it times 9, I get that denominator 72, so I got to take the top times 9, and I get 54. So that is 54 70-seconds. So what's bigger, 56 70-seconds or 54 70-seconds? And in this case, it's 56 70-seconds is slightly bigger by 2 70-seconds. And so that's not very much bigger because 70-seconds are very small. So I know 7/9 is slightly bigger than 6/8. So I'd probably just go in here and make it slightly bigger. And I can put in my 7/9 there. And then it makes sense. And I can prove that it's just a little bit bigger by using those common denominators. And we've got the same situation down here with 3/8. 3/8 is a little less than a half because I know 4 is half of 8, so that's less than a half. So I know it's less than 6/12. But again, it's pretty close to 2/6. So maybe I want to use my common denominators again. If I have 2/6 and 3/8, and I know 6 and 8, I can get them both to 24 just by knowing my facts. Now I've got to take the 6 times 4, so I take the top times 4, and I get 8 24ths. And 8 I have to take times 3 to get it to 24. So take the top times 3 and I get 9 24ths. So again, very, very close. So 3/8 is just slightly bigger by 1 24th. So 3/8, I'm going to put really close here, but it's slightly bigger than 2/6. Okay, so some of these guys I was able to use my number sense, like with half and those things, and know where they go. Sometimes I use common denominators if I'm not sure. And again, some of you may be able to reason that out, the size of the pieces, but we want to show you some concrete things that you can do just to double check and make sure. Okay? All right, last one, number 4. We're going to zoom in here and find 2 fractions between 5/6 and 6/6. I'm just going to make it easy here. I'm going to put 5/6 on one side and 6/6 on one side. We know these are both less than 1. Okay, so I'm going to zoom in. And when we zoom in on this, guys, one thing we want to talk about here is, again, sometimes the zoom in make them bigger. I'm going to kind of go a little bit larger right here and extend this a little bit with my number line. Okay, and I'm going to zoom in here and I'll make this number line. Again, not the straightest there, but we've zoomed in a little bit. and I'm going to make a new denominator. And because I know I'm going to have smaller pieces, and then I can fit pieces between here, because I know there's always fractions in between fractions. Remember, if you would take it times 3/3, you would get 2 answers in between. If you take it times 4/4, you would find 3 fractions that fall between here. So it says we just need to find 2, so I'm going to multiply this by 3/3, and that's going to change it to 15/18. And I'm going to change this and take this. I want that 18 common denominator, so I'm going to take it times 3/3 as well, which is going to change it to 18/18, which is 1 whole. So my job is to find 2 fractions in between there. Well, I can easily do that now because I have 15/18 and 18/18. So I know I can make 2 ticks in between there, because after 15/18 is 16/18, 17/18, and then 18/18. So I found 2 fractions here that fit in between there, 16/18 and 17/18. So that's just a sample of a couple that could fit in there. And remember, there are infinite answers here, and we could keep finding fractions between fractions because they get smaller and smaller.